Hey Musan, what's up, man? That's what we will find out today. Yeah, I'll wait a few minutes, 1 or 2 minutes, and then I'll start. How is it going? Chat should say something. Yeah, I know, but later is here in Netherlands will be quite late. It's 8 already, and I will probably 2 hours until 10. Why don't you move here to Europe, and then no problem with my stream time zone. When you come here, I will stream in the morning. Okay. I guess we can start. Let me put that down. So basically I wanted to do something with parser combinators. I've been using them in Haskell for very simple parsing. And the concept is it's quite cool, so I wanted to see if I can implement something in Reason, and the reason to do that is this. So of course I could do this with regex or something, but so here in the stream I have this text here, which is basically just a text that comes from JSON, and I could of course use Markdown, but it seemed like a good opportunity to try to implement a parser combinator myself. So the idea is that I will be able to parse these, and then the links which follow the Markdown format could be rendered as links. Yeah, so parser combinators basically are a way to implement parsing. I'm not familiar. Yes, that's what I want to parse, but you could parse anything. You can parse like a syntax for a language. You can parse I don't know, whatever that you want, and it's usually more like it's nicer to do it than regex. So I'll show some examples. The examples I have are in Haskell. So basically in Haskell I was using this library called Parsec, and then they implement a lot of combinators and basically the parsing as well. So one example was let me see. I think in this to-dos library. So what is the idea of this CLI is that you write files with your to-dos, and every day the CLI creates a new one. But this is not loading. Okay, let's show it here. So have to do and completed, and then you have a list of things, and then you can complete them and they move here. So for example, to do stream about parser combinators, and then when I'm done, you move it here, and the library creates like a new to do every day. Okay, it's here, basically this format. I accomplished or completed. And the parser for that, it's quite simple. So yeah, parse to do file. So how do you parse a to do file? First, I parse the to dos, which was this line here, then many lines with the to dos, then an end of the line, then the accomplish, and then it can be either end of file or many more lines, which are the accomplished ones. And I implemented this initially in Go with like regex, and one problem I had was that you couldn't have like the hyphen in between, because the I couldn't get the regex right to do it, and it was all error prone. So yeah, this is one example. Sorry for those that aren't familiar with Haskell for the syntax, but I'll explain a bit later. Another example. So these are basically simple things I did. So there is some parsing in one of these ones to parse the metadata of a markdown file. Yes. So no, not this one. Yeah, so this, for example, gets the first image in a markdown file, so it ignores the spaces, then parses the first line of any characters, then more spaces, and then parses any characters until it finds this string, which is how the image starts in Markdown. You write it like this with the alt here and then the URL. So it extracts the content of the definition of the image, basically, and then it returns the rest. What was the other thing? So that's not for the metadata, but that's doing some parsing. Not this. So it's going to be here then. Yeah, strip meta. So this one, for example, again parses any spaces, then finds the string with like 2 characters. So metadata in Markdown looks like this, and then you have key values like foo bar, and then this is the content. So yeah, it finds the first line, then all the meta, and then until the end. So it keeps trying until it finds this, and it returns the content. So after it parses and removes the meta, like with this is ignoring, it returns the content. So this can also be done with regex, but it's hard to, and all the memes about like not ever learning regex and or regular expressions, and then like having to Google and everything. So the cool thing is that these can be like parser combinators can be composed. That's why they're called combinators. So you compose like one, combine them, all. So here, for example, this Parser library defines ones for characters, where you have like the basic ones, like for so one character or spaces or a new line or tab, digits, and then you have more advanced combinators like between, so you could parse something that is in between brackets or many. And yeah, so the idea is then, because I'm using created, so I'm using for my website, I'm using Next.js with ReasonML. So I want to see how far I can get to implement like a simple version of Parser combinator where I could be able to transform these comments, and then I will have the links here and here. Yeah, so that's the goal. And please ask any questions if you have, or like if I should explain something better in the middle. So parser that okay. Great parse. Yeah. Yes. And if you're not familiar with Reason, the syntax is pretty similar to JavaScript, and I'll probably explain the differences. Yeah. So basically we need a parser, and as a disclaimer, I'm not familiar with the theory behind parsers. Like I did a few tutorials on like how to write the simple compiler, but I haven't took any classes in college from that. I dropped before, and I watched one or two tutorials a while ago about writing like a Parser combinator library. So that's all I know, and I'll see how far I get with that. So basically we need a parser of some value, whatever it is. So this is a generic here, and the parser basically will take some text, will be a string, and it should return that A. So of course I have a syntax error. I never remember if generics in Reason function type parameters. Okay, it goes before, and this is probably only like this. Yes, that works. So the parser gets a string and returns parser of A and return that A. So we could say that let a parser of a character of parse A, for example, would take the text and to switch on the string and if it's A, it will return it, and otherwise, what do we do here? So we probably need actually option. Yeah, so option can be either something or nothing there. So here we'll return some, as we have the A, and otherwise we'll return none. But well, this could only parse a single string. So if the string had more content, it wouldn't. But also, you couldn't combine this. So in order to combine, what we need is to actually keep track of the result of the things that are left, the text that is left to parse. So actually this will be like a tuple of the rest and the thing that we parsed. So reason, so string so I think we can use this, for example. So to parse like some arbitrary string, call it this, yeah, let's call it string. So we could say that what was it? Oh, but this is checking for a single character. And I actually want to see if it's a string, not the... Okay, I'm getting lost into string methods instead of parsing. This is for regex, reg expressions. Okay. Let's see. Maybe she is a string. Yeah, so char at 0, so we could do the string char at 0. So for again the parser for a, parse a, which is a parser of char. So at 0 if it's a, return some a, and we should return the rest. So basically every time we match something, we return that and the rest of the text, so we can keep parsing. So again, if we will parse here, this should return let's remove the first day. Should return that and some a. So this will be substring from 2 some string to n. Yeah, from and if we fail, like if it's not the a, we return the string untouched. So there are probably some think tanks, yeah, something that's unmatched. Yeah. Ah, yes, yeah, so that works. So we could parse a, and we could actually make these gets us any char. So actually instead of a here will be char, and it has to be a way to make a string from a char. Neat. Char. No. Konkatsu. Okay. Yeah. So to match that, actually, instead of This is then return that, otherwise let's see. Okay, what's wrong in here? Yeah, I don't have a okay. Pattern matches values of start type char. Line 5. Ah, yes. This is type of char to parser of char. Yes, so that let's call it char. So we can create parse a then, and these then we can say parse a b c, and yeah, so then this should be something like that. And if we like to parse the whole thing, we will say parse b and c, and this is where we will need the combinators and something else, because these so basically we parse here the rest and the a, and then parse b, which should be with the rest. Let's call it rest 1, and then rest 2, and we rest 2 we parse c. So this is b and this is c. This is a bit annoying to do the chain and keep passing around, and this also could fail, and then we actually wouldn't have the result. So before we do that, I just want to test that this works. So let's do the good old console login. So I'm putting the about page, or no, the index. Let's do this in the index. So this is parser, right? Actually, parse is the module, and then Yes. So yes, log. That's something I always forget. JS log. Yes. So please chat if like there are any questions, or if I need to explain something better, ask. So what is the log rest 1, and this should be rest 3 actually. Rest 2, rest 3. So in here we should have B and C, here we should have only C, and this should be an empty string. And yes, this actually takes only one argument. So this is 2, this is 3. Yeah. So local host. Oh. 9,000 then. $3,000. Yes. So good console log oriented development. Yes. So in fact the first one returned the rest of the string, so it was the B and the C. The second one returns the C, and the third one is an empty string. This also runs here. Why? Because this is a static page. Okay. And what do we have? B and C. Okay, so these are basically the character code. And what if we were to instead, so from here try to parse, for example, a T with rest 3. Yes. So T will probably be undefined. Yes. And that basically means that we got the none. So instead of adding any like wrapper value, I guess that Reason just gives you the value if it's there, or the undefined if it's not. There is probably a better way to log that, but for now that will do. Okay, so we see that it's quite annoying to pass around, and in the example I show from Haskell, so this is parsing spaces, this is parsing this string, and with the arrow we get the result of what we parse, but we are not passing anything around. And that it's because there are some functions that are used to run these parsers. So for example, in our case, if we were to write the function that parses like ABC, we will need to do quite some work. So let's take this back here. So if we say let ABC, it's a parser of string. So it takes a string, and we cannot parse like that because this can be anything. So we actually need to switch on the parse A, the string, and then we get the str1 and the A, and this will be actually sum A. So if we have the A, we return it, we keep parsing, otherwise if it's none, this goes away. And switch, it's basically like doing pattern matching, so it's like kind of like the JavaScript switch, but with matches against the structuring here. So if this is something, we then continue, otherwise we return the string without any changes. We didn't consume anything, and none, right? And then here we will do pretty much the same. Let's put it. So we will parse B, but using string 1, 2, and if we have something, so let's say we parse only A and B to make it simpler. So we return the result of like the string that consumes all of that, and then sum A and B. But this is besides some errors, no errors, this is like a mess to write. So we actually want some ways to combine the parsers. I think first of all, yeah, let's continue here. So this is the like combining two parsers only, and this goes like forever if we need to like combine several parsers. So how we will parse, for example, so the string that I mentioned, so there is some text, adecito, maybe in English, line 20 here, yes. It's still not formatting. But yeah, warning. Use it variable A and B. No. Anyway, it doesn't matter if this is not like fully correct, the syntax, but you get the idea that this will be quite a pain to write like combinators like that. So what I wanted to parse is like some text, and then like link text, and then URL, right? So what we should get out of this is probably like a list of text or link. So because we could have some more text and another link. And even more text. So that's what we want to parse at the end. So we could define now No, but let's define first the combinators, and then so the way this works in Haskell is basically this is using something similar to async await. So this thing called do notation, it's like the async keyword in a sense, and this arrow is the await, but this is generalized. So in JavaScript, if we write an async function that await on some promise a of a, and then a and of b, right? And then we return a and b. So what these kind of the sugars do is I don't know the real implementation, but this will be something like some promise of a, then a, and then here we return some promise of b, and then we have b. So we can just return the a and the b, right? So this syntax here in Haskell is kind of the same, but for the flap map or the bind operation, which is basically what the monad, the operation that defines the monad. I won't explain monads or anything, but it behaves similarly to what we are doing here. So we return a promise of a promise, but it flattens and we only get a promise out. We don't need to do then and inside then. But it's generalized for any type. So for example, if you have, so you have this do notation, it's like for a function do, and then here you could have some a, and this will give you the a here, and then so for option it's defined, and for any, like for other types as well, and it's also defined for a parser, so you can get whatever is inside the parser, and yeah, so we could define that for our parser, and so it will be something like type let, and then which will take the signature is m of a. Let me find the signature. I know it by memory, but somehow I forget now. So this is the operator that defines this. So basically what is saying here is that given a type like a monad, so this can be the promise or this the option or whatever, you have the monad of something inside whatever, and then a function that goes from that type A to the monad of another type B, and then it returns the B inside. So then we'll take a parser of, so let's say PA, which will be a parser of A, and then the function, which will be function from A to parser of B, and this would return a parser of B. So yes, and so we need to return a parser of B. So a parser is a function that goes from string to, so let parser P. It's a function that goes from string to something, right? And here inside this function, what we'll do is we will parse we will parse PA parser of A the string and switch on that result. If that is rest sum A, we then call the function with our A, and this gives us a parser of B. And if there is none in here, we just return the string with none. So parser, there is some syntax error here. I don't know if it's the way I'm running, but these errors are not helpful at all. So we should return the parser of B. So instead of defining it, we could just return it. And then basically we don't need this either, but syntax error. Next 25th. Let's ignore that. Expression has type parser B. Strings B. Okay, so 6. I'm missing something here. Because we need to do something with the rest, right? and same here. So or not. What do we do with the rest? I run the first parser. That's the formatting. Yes, formatting works. Okay. So this is supposed to be the parser of B. I couldn't run that. I need to do something here actually. Yeah, so this is a parser of B, and actually I need to run it with the rest. Yes. So how would this look like if we use it? Let's keep this parser here. So let's say we parse. This is parser of A and B. So, and then takes parser of A, and then A. Parser of B. That AB. Okay. So let's throw away these. This is parse AB. So, is this working? Okay, so it seems like it worked. And to see if it worked, so let's go back a little bit just to, yes, where we had the parser of AB, which besides that it has syntax error, line 28. What is the No. No. Let's use it in line. Sorry, I hit the mic. So what is... Anyway. Besides the syntax error, this is how you will define the parser of A and B, and actually here we should actually do a bit more. So this actually parses B and ignores A. So what? And let's call it parse A, parse B. So parse A, parse B. But what we want to do first, let's use the pipe operator, parse A. So we want the parser to be the second argument, not the first. And now we could do so we could do something like this, where we return and A and B. What's wrong now? 27. Syntax error. Yes. Type option A. Yeah. So that works, and what probably gets us. Yeah, so this is the first line that we are logging, is the rest, and this is the result. But we are ignoring quite so many things here, so we could define, but because what we want to transform now, it's the thing that is being parsed, but we are not doing anything. So we can define something similar to this, which will do map instead. So map, and the function will not go from a parser, but it will just transform what is inside. So so now what we transform is whatever we parsed, and this is rest. And this should be inside the sum. Yes, so now here we could then, so we parse A and we ignore the B that came, we parse B, and now we map that to AB. And that should work. Yes, so that still works. So now we can combine the parsers like that, and we could like nest this piping if we need to do something with the results. So this is basically a functor, makes our parser a functor because it has a map, and this makes it a monad because it has and then there are some other things missing, so the other thing will be actually, let's define it, let of takes a value A and returns of type, let's not give it, and returns a parser of type A. So this is of type A, and parser of type A is just a string that returns the same string and the A in there. Of, let's call it pure. Pure, it's probably also a reserve word. No. Okay. Oh yes. So okay, so pure, it's how Haskell calls it, or return as well. Maybe return is not a reserve word. Yeah, return is not a reserve word, but that's confusing for those that are familiar with JavaScript. So pure basically is a parser that always returns the same and doesn't consume any input. So and there is one more thing reminded for monads, but let's try to do some parsing first if we need it. Actually, pure is not from monad, it's from applicative. So the hierarchy is like this. So we have functor, which has map, and then that is dependency of applicative, which has pure or off, and that is, and also up or apply. Let's call it apply, and then that makes monad, which has the and then or bind or flat map. And we could define the apply, it might be useful. So what applies that, if we see here, what map lets us do is apply any function that goes from A to B. So for example, we have what could define reason string of int. No. Okay, let's say that we have a parser, the function length. So we have a parser of a string, and the function length, it's of type string to length to int. Sorry. So we could use this length on any string, but if we have a parser of a string, we can basically map it. So do map, and we apply that inside the parser to whatever the value that was parsed. So length of parser of a string, like for example AB was our parser of a string. But if we have functions that take more than one argument, then we cannot do that. So for example, add takes A and B, any A and B numbers, and just adds them together. So we could not map with add a parser of int, because add take two arguments. So what applicative brings here to the table with apply, or let's call it app, that's how other languages call it, is app. So there is a parser, and this is it was the hardest thing, like for me to like see the usage of it, is that we have a parser of a function, and then a parser of A, which is parser of A, and we return a parser of B. So instead of having a function that we are going to use to map, or a function that returns a parser and then we unnest it, what this one does is that there is a function inside the parser, and it makes sense once we see example. So again, we return a parser. So the parser is basically a function that takes a string. Can you format this from? Yes, so we switch again. So what we do first is apply the first parser, which is the one that gives us a function, to the string. And so this one will give us the rest and the sum f, and we will do something, otherwise ignore the rest, have a none, and we return string with the none. So what will we do here? Well, we now have a function, so we could map our parser of A, because this function is from A to B, and we have a parser of A and we need to return a parser of B. So we could map, which takes an F and a parser of A, and that's it. Unbound time constructor A. Yeah. How can I start in line 14? I don't know if I can do this. So what if I put this first? So the A isn't unbound anymore. Unbound and constructor A. It's still unbound. One second. Okay. So why did it work here, but it doesn't work here? I guess. Does it need parents here? No. Okay, so this is basically the right signature. No, it doesn't need like TypeScript. But so in Monad is an unbound, but here somehow this is unbound. Now higher order functions in the manner. No, not TypeScript. Dev2 is slow today. Or my internet is slow, I don't know. Yeah, but how to write a function in reason with the type direct to any type of parameter. I need this. Not expert in type inference algorithm, but okay. But how do I place that? Universally. Generic reason. Quantify. ReasonML. So yeah, that's what we define this map. Does someone in chat see it? First. No. Maybe in the implementation of applicative I can find the same type signature. Wasted so much time on this plan. This is what I'm doing. I'm back. I'm a bit confused with this. So here I think what it's doing option applicative. I'll apply. Okay. Type apply AV. Okay, I could define the type. Type. AP, which is text A B, and then it's this parser. Okay, so this is the same problem. In line 14. This is the list of A, B, list of A, list of B. Oh my god. Please tell me that all this time the only thing was that I had that switched. Yes. Oh my god. I wasted like 10 minutes on this, I don't know. Okay. It happens in programming. So type parser B, string option B, but an expression with spectrum type string option B at line 16. Yes, because we need to apply the rest. Yes, so now with applicative, what we can do is so let's say you have a function that takes 2 chars. That function that takes tuple, so it takes A and B and returns A and B. Yeah, so this is just a simple function. So what we could do is it could A and B tuple, we could parse A, then we apply our so sorry, no, we put our parser, our function, our tuple function inside a parser. So now we have a parser that takes a function that goes from A and B to A and B, right? So if we apply the parse A, now we have a parse we have a function so this is a parser. Now we have a parser that goes from B to A of B. We apply the first one, so it returns us a parser of the second one, and we will apply B, and now we have a parser of A of B. Expression as type parser char string line 53. Okay, so we need to take the parser first. Yes, that works. Confirm. Yes, that works. So we put the function inside the parser, like a pure one that will not consume anything, and then we apply the first argument, and then we apply the second argument. And we could define operators for this, but let's not do that. Okay, so now we have all we need to combine all these parsers. Now I need to implement parser library, the parsing basically. So char, I don't think I'm going to be using it. Let's keep this here. So what we need is so let's define a type of b. So grateful for now, and this will be a list. This will be either some text which will have a string, or a link which will have 2 strings. And what's wrong now? It needs define like that. What's wrong here? Today is the day that I don't understand reason syntax. Is text the type? How did I define? This should be capital letters. Okay. So this will be the nodes basically, and then type mark down it's a list of nodes, right? So this is text with links. Text with links is a list of nodes. Okay. So we first need to be able to parse. Let's start parsing the links. And so to parse the links, we need to parse the links looks like this. That link. So we have some text. Some url.com, right? So the link. So to parse the link, we need to first parse something that is in between these, and then something that's in between. Yeah, so let's do let link text, but first I need to be able to parse text. I need to be parse characters, and let's find out how we string model string. So make neat superstring combinator stream caped index index. What do we have here? Let's make two. Char add cut. The Explorer starts with yes. So let's implement the between parser, so in between text. So we can say this is for characters, but the only thing is we don't have a way to comfortable way to put characters inside, but anyway. So what I want now is let between. So we will take a parser of start p and end. Probably should put it like this. So we will parse p and we should basically return So this is a parser of unit, so that thing doesn't do anything. Another parser of unit, and this is a parser of A, and we return a parser of A. So first we do start, right, and then we have unit, so we ignore it. We do P, and then, and here is where we will do some nesting because we don't have the do syntax from Haskell or the async await one from JavaScript. So then, and then again, so we have the, say, yeah, we have the A. We do parser of, we do the end, and do end, but then we map to P. And we probably have some syntax error. There is syntax error here. Unmatched. The unit parser. End. So before what is wrong with this? Do you see any syntax error? No syntax error. This is okay. Some unit type. No. Okay. looks like it's not a type. So let's say that this is a parser of A. And this is a parser of B. This is parser of C, and we return C. Type parser string. Parser. Parser of parser. Where? So we could map after to a P. Make it like that. Why? Doesn't type check. The expression has type. If I run FMT. Okay, not very useful, but so, and then this is a parser, right? Parser of C. So I'm nesting something where it shouldn't. So before this is yes, that works. Okay, so this is still a bit hard to follow, but it's much easier than if we had to do manually all of these. So let's remove it, remove this here, and let's remove these which we're not using. Okay, so now I can run define let between brackets as between char and okay. Goes from parser of A to okay. Will probably be generalized once I use it. So between brackets, but now I need to basically be able to parse any text that is not the closing bracket, right? So that's what we should be able to have inside. And how will that work? So is there a way to get custom right like link? Think and it is stream to by start. Okay, so we could define, actually we could define the string one. This will be a string to parser of string. To match so if substring so if it start with that, if otherwise none, but probably substring, yes. Yeah, the same thing, but what is this? I guess we could do this. But it's actually replace. Okay. So substring, new substring, string, substring. Yeah. So this is basically the same, but cool. Instead of characters, we could do strings. Of course, we have some error. Syntax error. So what we return is some substring. Okay. Anyway, what I want is so I want to match any text that is not close brackets. And so I should probably take get string. So one cool thing that in Haskell is that you can pattern match on strings because they are actually lists, or the simple version of things. Yeah, it's not very performant, but for these things. Because I will have to define a parser that keeps parsing, like if the first element is not this, right? So let's see what Parser defines. What is there in parse? One off, none off, spaces, space, new line. Any char. Satisfy. So we could do something like char is. So we take char bool. Oh. Sorry about that. I guess it's time to end. Anyways, basically I need to define the small little parser that I should combine to define the to be able to parse this. But it will be something like, so for the link it would be between brackets it will be let any text not closing bracket, it will be a parser, it will be let link text will be any text not closing. Yes, and then parents, so that would be the link URL, and then that's it. So then you construct the link, and the text is basically any text. So let text, this is the link, but if there is some text here and some more text here, so the parser will look something like this. This will be any text not opening bracket, right? And then that will parse until here, and then you will parse the link with the link parser. This is URL, and then you will parse text, and then basically what you would need is like a optional parser that can parse, like, try several things, because the text could start with a link, for example, or could only be a link. So if this is a list, or could be empty as well. So these are all valid cases. But yeah, that's for the next time, because it's already late here. I have to go to sleep. Yeah, so thanks for joining, whoever is still in chat. I hope you have a good evening or afternoon or night or whatever. Bye bye.